Welcome back to Broken to Build. Today we have a patient that most mechanics would consider a total loss. This is a professional grade 3 1/8 inch Guidor combination wrench. As you can see, the box end has completely sheared under extreme torque, leaving it useless for any serious industrial work. In a high-stakes environment, buying a replacement for a tool of this magnitude is expensive and time-consuming. Instead, we're going to perform a mechanical bypass by machining an entirely new structural head from a solid steel billet. This isn't just a fix, it's a complete re-engineering of the tool's geometry. Let's get to work. The first step is a clean surgical cut. We use an industrial chop saw to remove the fractured remains of the original box end. We have to be extremely precise with our entry angle here. We need a solid perpendicular mating surface on the wrench's neck to ensure the new head sits true. Once the damaged head is removed, we move to the lathe to face off the end of the chrome vanadium handle. This provides us with a flat, clean surface that is essential for a high-strength metallurgical bond. Any oxidation or unevenness at this junction would compromise the final integrity of the tool. Now we shift our focus to the new component. We've selected a solid, high-tensile steel billet for the replacement head, chosen for its ability to handle immense radial pressure. On the lathe, we begin by facing and truing the billet to ensure absolute concentricity. We then move into the boring process, cutting the central hole that will eventually become our hexagonal socket. This is precision machining at its finest. We are working within extremely tight tolerances. We utilize a specialized setup on the lathe to cut the internal hexagonal profiles, a task that requires multiple delicate passes to ensure the tool perfectly grips the fastener without slipping. With our new head machined, it's time for the critical assembly phase. We align the new steel head with the original Guidor handle. This is more than just visual alignment. We use magnetic levels and precision blocks to ensure the head is perfectly centered with the handle's longitudinal axis. Any minor misalignment here would make the tool awkward to use and could lead to uneven stress distribution under heavy load. Once the geometry is verified and double-checked against our measurements, we secure it for the most critical phase, the deep penetration structural weld. This is where the tool regains its strength and soul. We are performing a high-amperage multi-pass weld to fuse the new high-tensile head to the original handle. We are just joining the surface. We are creating a solid, unified structure capable of withstanding the massive leverage this wrench is designed for. We manage the heat carefully to avoid making the steel brittle. After the weld is complete, we use a precision grinder to smooth the transitions and remove any stress risers that could lead to new cracks. This finishing work ensures that the torque is distributed evenly across the entire weld joint. The transformation is complete. We've taken a piece of high-quality scrap and re-engineered it into a tool that is arguably stronger than the day it was manufactured. This is what we do at Broken to Build. We resurrect industrial power from the scrap heap and prove that quality engineering never dies. If you enjoyed watching this mechanical surgery and want to see more industrial resurrections, make sure to like this video, share it with your fellow gearheads, and subscribe to the channel. Your support keeps the workshop running. We'll see you in the next build.